Welcome to my channel. This part, this video contains analysis, design, and detailing of RCC building part 2. This is data for analysis and design. Total number of story G plus 2, foundation depth 1.75 meter, plinth beam sizes, column sizes, slab thickness, imposed load, floor finish, then everything before you start your analysis and design. These basic data are important. Now let's go and start. Right. This is my center to center distance. This is my plan for the building. So I just did a copy and for better understanding the views. And in this video, we started from AutoCAD. So how to draw the AutoCAD plan and export to building planner and analysis in STAD Connect Edition and detailing in RCDC. Right. So let's start now. Then first one, they open the AutoCAD. Right. So go to the first setting the units for our unit setting decimal. Then changes my insertion scale to meter. Okay. Now choose REC rectangular dimension. D enter 7.42, then 6.86. Right. This is first. Okay. And before you start the drawing, so one more thing you do. So setting the layer, new layer setting, create a new layer. So in that I using the slab and changes my color to pink color. Then I choose the slab. Okay. So now you start now. Rectangular dimension 7.42, then 6.86. Click it and then 5.10 REC dimension 5.10, enter 6.86, enter. Now and third one 5.64, again I choose rectangular dimension 5.64, 6.86, 4.58 rectangular dimension 4.58, enter 6.86, enter. Then 5.22 rectangular dimension 5.22, 6.86. Then 4.93 REC dimension 4.93, 6.86. And next one 3.14 REC dimension 7.42, then 3.14, and dimension 5.10, then 3.14. Now 5.64 dimension 5.64, 3.14. Now REC better connect like this, then REC. Right. So now we completing our line sketch. So the slabs are like this. Right. This is a polyline basically. Right. Now I save it as so DX of file. Better I choose 2007 DX of file. This is tab 1. Start planner for identification. Save it. Now just close it. Okay. Now so open my start planner, building planner. Yeah. So project, client name, engineer. The number of levels, so already we discussed. G plus 2, so totally 3 story and foundation 1.75 meter. Okay, so totally 3 plus 1, 4 levels are there. Number of levels is 4 and foundation depth indicate 1.75 meter. Create a project. Then first step, the floor height. Floor height is here mentioned, so I take, oh yes, mentioned. Floor height 3.15 meter. Uniform. Now plan 1, plan 1, plan 1, plan 1. Typical floor plan. Then floor finish, maybe take it as 1 kilonewton per meter square, 1.0. Live load 2 kilonewton per meter square. Then the thickness of wall 0.23. Then grade of concrete is M20. Then 500. Later we will change it to 550. While designing, we will change it to 500. Sorry, okay, 500, no problem. Then now import my DXF file. Go to, and before that you change the unit meter. And desktop start planner. Okay, create a plan. Yeah. So now it's easy to import. Now, so the 0.2, 0.15, 0.7 are the slab thickness, right? So first you change the thickness for select all, right click, set property loads for the selected slab. Now the grade will not be changed 20. So thickness is zero point 0.2 mentioned, so I think it's 0.15. You can change the thickness for each and every slab. Floor finish, yeah, 2 kilometer. This will not change. Okay. Density of concrete. So others are same. Okay. So changes. Now auto beam changes the size 0.45. External beam also 0.45. Grade okay. Now so the red and blue are indicating the splitting the beams because we are take it a single line. So you need to break for separating the beams. So either you can use blue line or you can use red lines. So I use red lines for the splitting the beam. So now our beam is ready. Now placing the column, auto column, so like this. But initially, the part one video I mentioned, the initially the start planner assume the column size is zero point 0.5 by zero point 0.5, right? Now go to analysis and finalize your plan. Yes, with continuity means, for example, 209 for 27. It is axial load. For example, I place the without continuity, it will take 235.79. So it is little different. So with the continuity or without with continuity, right? Okay. Now workplace converted to 3D frame. Yeah, ready. Now assign column size and orientation. Now changes your resize the column. Now first one breadth is 0.23, then 0.23, 0.23, depth 0.45, 0.45, 0.45, then 0.5. Check the design. Okay. Now 90-degree rotation, then offset like this. Now copy this one and paste it over entire plan. Just press Control V. That's all. I'm doing Control V. Now you're changing the orientation of column. It is very must like this, and also inside the column. Now copy, then press F4. Press F4. Okay, I think it's okay for now. Right. Now just copy, then F4, F4, F4. Now and is ready, and just close the window, then analysis, generate analysis file. First save the project, save as, and desktop. That I mentioned part 2 for my understanding. Okay, now generate analysis file and action. Okay, that's all. Okay, just close it and save it. And go to residential, and your part 2 video is, sorry, part 2 file is ready now. Just open it. This is the view. It's running. Yeah. Look at this in 3D window. The proper finishing. There is no edges. All the members are properly offset. Okay. Right. Now you're going to analysis and design. Right. Okay. Then okay. So file and put it as save as. Now go to desktop residential. It is residential one. Or take save it as it is. No problem. Just to save is okay. Save. Yeah. So your file is saved now. Now, okay. So our file is ready, right? And the design, concrete design. Now the envelopes, go to new envelope, then load combination, and selecting the members, front view. I select only beams and go to members in the menu bar and auto form members. Now the members are take it as a continuous beam. But in normal Stat Pro, so when you're using the design, so it will take individual member. For this interactive design, RC designer, so it will help you to so take it as a continuous beam, right? Okay, now go to the group and briefs, new brief, EB. design code IS456B. Now, the changes of the design parameters M20, they are divided into 12 sections. Okay, then main reinforcement. So I'm basically 12 mm. Bottom member also 12 mm. Maximum size is 40 mm. Then bar type FE 500. So if it is 550 means user defined, this is there 550 also, right? You can give. Okay. Now 500. Shear reinforcement started from 80 and it is 415. So for shear bar type, that is stirrups, so you must use FE 415. It's not available 500, so it is 415. So the design shear for you may use center line support or column faces also. Right. So column faces is very easy. Right. Now select all the members, design group, design. Now go to mode, member design. Go to design. Right. All the members are passed. Look at this. Okay. Except a few members, the black colors, this file. Okay. And then the summary and main reinforcement summary also is there. ST requirement. Okay. Now go to file, report setup, then main steel summary, then reinforcement bars, span by depth ratio, detail member for all members. Okay. Now print a preview. This is your the for each and every member, the sections are divided into 12, and the main steel summary is shown as like this: AST bars in the bottom layers as well as top layer. Then you can also check the manual calculation also. You can check report setup, design details are available. Okay, design details, members. Okay, now print a preview. So totally all members, the member is safe, the command is also there. Member is safe. Then totally how much members? Sangrange length. Yeah. Span by depth. This is a calculations. So how they are calculated? So they take values, span length, width, and top and bottom covers, depth of sections, and the member one detailed IS 456 main reinforcement started, then moment application 177, then D dash. So it is a manual calculation, right? Close it. Yeah. Similar way you can design the column also. Okay. The remaining details RCDC we will discuss next part. Thank you for watching and subscribe to my channel. Thank you.